Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 8, Lesson 1, on Conic's Basics. Sorry about that, I'm doing a video in the car today, and that's what I had to do, because it's hot.
Well, BPM Music, 93.1.
Okay, sorry, the radio's off. So Conics, this is the last unit that there is. I accidentally said that there was going to be 9, like at first I said there was going to be 7, then 9, but actually 8. Because I realized I was going to do something in one unit. So, sorry, I got sidetracked there. Different intro for this unit, because that is instead of the usual Black Bonzo Swedish song, there is Harry Connick Jr. song. That's Conic's, that's why I did that. So how do y'all know? And a picture of a YouTube channel that you should see, another one, Shush Conic. So that's what you should follow. SHH Conic, not spelled like this Conic. Well, I don't know if you know who Harry Connick Jr. is. Probably, maybe not. But that's not the point. This isn't about that. This is conics, and conics are a shape that could happen from slicing a cone. So now you might think, that's dumb. That seems like geometry. Well, it's kind of like geometry, but still, these are what conics are. And when we did quadratics, that's a kind of conic, which is parabola. So there's the 4 kinds, and I will show you what they are. So let me just do, what should I do? Pink, I guess. To show you different ways to slice it. So the first one is a circle. I know this is 2 cones right here, but that's just for the purpose of the hyperbola that we'll talk about. So if you slice a cone directly straight like that, you would see that there's a circle. So that's one way. Then ellipse is like a circle, but instead it's if you cut it at an angle, not just straight. And we'll look at what equations looks like for that. Then parabola is if you cut it directly vertical, kind of like this. Then you slice off a piece, and if you were to slice that off right there, then you would turn it over and see that it looks like that, and that kind of looks like a parabola, which is like the quadratics. Then there's hyperbola that has 2 parts, and that's if you cut it like this. So that's the different ways that you can cut that, and those are the things you can get. So this is what the shapes look like. There's a circle. Hopefully you know what that is. Ellipse kind of just looks more like a oval, kind of. Then parabola, you know what that looks like, quadratic. And then hyperbola, there's 2 of those instead, and they're not exactly just like a U shape. They're kind of just almost like a V, but kind of a curved V, 2 curved V's. So the equations differ between these conics. When set equal to 0, so we're looking at a form when they're set equal to 0. So if something's set equal to 0, then for it to still be an equation that you can graph, it would have to have x and y on the same side. These are the characteristics of the equations. So here's how you can know which conic it is. If it's a circle, then it will have a x squared and a y squared that have equal and positive coefficients. We'll look at examples soon. Then the ellipse has also x squared and y squared, but they both still have positive coefficients, but they have different coefficients. So that's why circles have more perfect shape, because if you think about it, if they have the same coefficient, wouldn't that make it more perfect? And then ellipse looks a little bit different because they might have different coefficients. So technically it's like those things like with rectangle, square, like you could say that circle is an ellipse, but it's an ellipse that has the same coefficients. I don't know, but that's how you can tell the difference. Parabola we know that it has either a x squared or a y squared. Usually we've seen that it has x squared because that is a quadratic. But if it has a y squared, then that's the square root function. You might be saying, hey, I thought that the square root function was this. And it is, but if you wanted it to be in a form where you could see if something had a square, like you didn't want a square root, then you could square both sides. The square root and square symbol would go away, and then you would get x equals y squared. So that's how that is. That's what I mean by that. So basically, for the parabola, only one will be squared. And they can have various coefficients, we know that, by transformations. And hyperbola, the difference between that and just parabola has both x squared and y squared, like to circle an ellipse, but instead one has a negative coefficient and the other has a positive. That's what causes there to be two things. And the coefficients can also vary on that. So let's look at examples of equations, and I'll say why they're like that. So basically, it doesn't matter what are all the other things that have no squared or if they're the constant. Just look at the things. I'll just underline the things that have a squared, and you need to look at the coefficients, like if they're positive, negative, or what number they are to tell. So the first one is a circle. Why? We see that the coefficients, there is a x and y squared, and the coefficients are both positive and they're both 3. That's why it's a circle. An ellipse, we see that is the exact same equation for that one. The reason why it's an ellipse is because the coefficients are 4 and 3, not 3 and 3. Then parabola, we see that it's a parabola. In this case, it would be a quadratic. And you might be thinking, that doesn't really look like a quadratic. Well, honestly, that's just because it's set equals 0. You can move this y, and then it would look like the form we know. It would look like this. So this is the same thing. That's why it's quadratic. Or, well, it's also a parabola. And so remember, like, that square root functions are still parabolas. Then hyperbola, we see that's a hyperbola because they have a negative and positive coefficient. So now let's see which graph goes with which. You could just say by looking at their shapes, but these are the actual graphs that go with these equations, and I'll tell you how you can graph those in the next videos, especially the circle, because that's difficult. Like, we already know how to graph, because like usually with the TI-84 that most students use, these pictures I screenshotted from Desmos, you can type them in. But on a normal calculator, you usually have to do it in a y equals form, and I would show you how to do that. Okay, so let's see. I'm not going to look back at the equations, but we can tell this is a circle. It looks like a circle. So this might be kind of cool to you if you never knew if you could graph shapes, and you can even graph squares, and I'll say something about that in a minute. This would be a parabola. We see it looks like a quadratic because it is. How do we know that it's a quadratic? Because it's like this and not like this. Well, square root functions are really like this, but if you have positive and negative, then they're like that. Okay, so that's why that's a parabola. Then the next one is ellipse. Now you could think that's a circle, but you can tell that this one over here is more like ovally than that one. So we'll just say that's an ellipse. Oh, that happens way too often. That's just because it, touch it. Ellipse. Alright, and then obviously, maybe you would think the last one's a hyperbola because that's the one we haven't done yet, but you can see it just doesn't look exactly like a quadratic because it's more like that than like that. So that kind of almost looks like the absolute value one if it had a reflection or something. So that's what that is, hyperbola. Alright, that's what those graphs would look like and what the equations would look like. Now let's see. Now you can determine well, you can call these conic sections too, and you can determine which one it is by doing this. If there's any square roots, it's easiest to tell when it's in the form where the x's and y's are on the same side and it's set equals 0. So to do that, you have to remove any square roots by squaring both sides. Then you move everything onto the same side so that there is 0 on one side. And then you take note of the x squareds and or y squareds to see. So let's do that. The first one, there's no square roots, so we can move everything onto the same side. We see that, well, you might already be able to tell this looks like quadratic, so therefore it would be a parabola, but just to show, we will move the y onto the other side. And so then we get x squared minus, well, let's just put the y right there, and then plus 3x minus 5 equals 0. We know it's a parabola because there is only a x squared. If there was a y squared, then that wouldn't be what it is. Okay, that would be a hyperbola if it was like that. Okay, so that's, oh, well, I might as well just write that, parabola. Next one, B, we see that there is a square root, so we need to remove it by doing a squared. And once again, you can already tell for this one that it's going to be a parabola also, because that looks like your square root function, and that is a parabola. So let's square both sides. Now we have y squared equals, that would just be x plus 2 instead of square root of x plus 2. Then take away the y squared to make everything on the same side. You get x minus y squared plus 2. Well, that's not really the right way to write it if you're doing standard form. Technically, you would write it like this. Equals 0. And we can tell that it is a parabola because it only has one squared. So, parabola also. Next one. So obviously we don't see an example of each one because that's not how it is. So now we need to square. Oh. Well, I just realized something. This is not even a conic because I already can tell that's going to come out with no squareds. So I think that I meant to do this. Well, this is not a very good example. Okay. Just because, as you can see, if you squared that, then it would just be y minus 3. That would end up just being a linear equation, not a conic. I don't know what I was thinking there. We will just pretend that there's no square root there, and that we have this. Oops. Okay, we want everything to be on the same side. Means we're going to need to do minus y squared, get negative 3 equals x squared minus y squared plus 4, add 3. Then you get x squared minus y squared plus 7 equals 0. Alright, so what is this? This is a hyperbola this time, because we have a x squared and a y squared, but since one is negative and one is positive, that's why it's a hyperbola and not a circle or ellipse. So that will be it for this video on conic basics. We'll go into more depth of these 4 things in the later unit, with the next lesson being on circles. So thanks for watching, and I'll see you on the next video.